Hello, welcome to Enots Engineering. I'm Alan. Today in the workshop I'll be taking the cover off the headstock on the milling machine. I'll look at the traverse feeds and see how the gears work, see what's inside, and also find out where the oil goes when you fill a small oil cup up on the side and it disappears into the head. So let's go into the workshop, see how it works. I've often wondered where the oil goes when you put oil into this little cap. So I thought I'd take the front off and have a look. So the first thing to do to take the front of this panel off is to take the grub screws out of the knobs. Each knob has 2 threads in it, and I've found on this one each thread has 2 grub screws in it. I removed the first set of grub screws. That seems tight. And there are 2 sets of grub screws in each thread. So once you take the grub screws off, the knob should just pull off easy. It's not a press fit on the shaft. So if you're still having trouble taking it off, just check that in the bottom you've not got another grub screw. So you do that for the 2 knobs. Then you undo the 6 screws that are around the plate and take off the pointer on the front. Okay, so once you've taken all the screws off, you can then lift this out. You need to move it over the first bar, then you can slide it across, take the cover off. So what do we have inside? We've got the mechanism for the depth gauge. On this machine I've got some marks here where someone's drilled and tapped 2 holes, and there are another 2 holes on the back, so I'm assuming there's a different type of depth gauge which used to be in the middle. This is just a adjustment. I was thinking of taking it off, but all it does is register the depth that you've gone when you use the spindle, and also this acts as a stop, so you can set the nut, and when it touches the bottom the spindle won't move anymore. So that's okay if you've got a lot of holes that you need to be drilled to a certain depth. You can set the stop and you know you're at the depth. There are 2 oil seals here on the spindles because this gearbox on the top has oil in it, and then in here you have the mechanism for the feed. So the fine feed. So what happens to the oil that you put in the cap here? Let's have a close look. So inside we've got the worm gear here, some sort of clutch at the top, another worm gear on this side. When I put oil in the oil cap on this side, it goes inside here, and you can see just at the back inside copper tube. Let's see if I can get in closer. There's a copper tube just inside, and all it does is drip oil onto the top of this worm gear. So the first thing I was surprised about is that tube had just got grease slapped in it, so any oil I was putting here was being held. The next thing I was surprised about was the amount of swarf that was in here. I've cleaned it out now, but I look down the bottom. Around the corner here there was a little pile of swarf in the corner, just as if somebody had drilled this hole through here and all the swarf had just gone down and was left inside. If you look further inside, you can see down here there are 3 gears on this shaft that drives the head, and there are 3 gears on the back of this shaft. These gears, the bottom here are dry, there's no oil on, no grease on. So what I'll do is put some grease on these. This oiler at the top here does not oil those gears. Any oil that's left over will come down here, drip on here, run down the bottom and run down the back, and as I've found out, just drips outside. So there is no special place in here for the oil to go. See the 3 gears at the bottom there, 3 gears on this shaft further back. Those gears there are to select 3 different speeds that you have for the downfeed. Now what you're seeing here is I've actually cleaned this, the amount of swarf that was in here. I was surprised. So I've cleaned this out. I'm going to grease up the gears, put some oil on as well. The bearings are sealed. Another reason why I took this off in the first place was to see how this was fitted. The depth gauge is just held in with 2 cap heads at the bottom, which holds this bracket, and there are 2 grub screws on the top, which holds the depth gauge. Take my lamp off. This is just held onto the spindle by 2 cap heads here. So as you turn the spindle up and down, this depth gauge moves up and down. And what I was looking for is if there enough room inside here to fit a proper DRO readout that I could link into a 3-axis one. I'll just show the gears working. I'll switch the motor on. You see the gears operate the down feed. As I engage it on this, the feed goes on. Now this is feeding down slowly. I can stop the machine. I can change the gear to a slower speed. On this gearbox on the side I have 3 speeds from 0.1 to 0.26, I presume that's per revolution. Here, I think this is like a little clutch that if something stops, for some reason it hits the bottom of something, this will just lift up and ratchet round on this part here rather than damage the gears. It's a shame really, because it looks a good machine and you'd think that if they've gone to the trouble of making castings and machining them to size and fitting all these gears, they'd at least give the castings a good wash before they assemble them to make sure all the swarf and bits are taken out, rather than to assemble it with swarf and bits already in it. You can see the tube inside. I've just put some oil in and the oil's just dripping out the tube onto the gear. See if I can get in the back with this oil can. Put some oil on the gears right at the back. I would say this cover probably needs taking off once every 6 months or a year to check on the gears, because that little oil dripping onto this gear won't oil the gears at the back underneath. I'll just show you, that's the sort of swarf that I got out of this little box at the top here. When you put the cover on, just make sure that the little marker inside here goes into the slot on the front. It slides up and down the slot. I'll just use a couple of screws just to hold it temporary. So now I'll put the knobs back on. I'm surprised the knobs are made out of steel. They could have been made out of aluminium, I suppose, but they're quite heavy for what they do. So you just make sure that the positions are right. Each spindle has a little indentation in it, so you can line the knob up with the spindle. That's the knobs back on. Now I'm just putting the screws around the outside of the cover. Now I've also noticed if you've got one of these feed motors fitted to the end of the table, on the instructions for this machine it says oil the oil feeds on each end of the spindle on the table. There's the oil filler on the other side, just a ball bearing. Well, on this end the spindle is underneath because this covers it, and the oil feed is at the top of the yellow piece, but you can't get into it. So what I've done is drill a hole in the top so I can feed my oil can through. Just above the oiler there. So by drilling a small hole in the centre, level with the feed oil filler, I can now put my oil can through the hole and oil. How often do you get this problem when you've got your Morse taper sleeve and the Morse taper inside doesn't come level with the top? So you can't use your drift to extract the inner Morse taper. All you need to do is find a little nut that will go inside, then you can put your drift through and extract the inner taper from the outer one quite simply. Put the nut inside, and then as the drift goes through, it pushes down on the nut and extracts the inner taper. Well, that's it for today. Hope you enjoyed it, and we'll see you next time on Enots Engineering.